morning, afternoon, everybody. It's been a day here. So got us I need to move some stuff around here quickly to make sure I can see what I'm looking at. Got chat open, should be good to go. So yeah, this is it's that time of year again. We're starting to think about planters and putting seed in the ground and getting our crops ready for the growing season. I will also say, if you're like me and you're just now starting to think about that, we may be just a little bit behind. So I hope everyone has maybe even started getting their planner ready. If the planner's not ready, I would say get started right now if you can. So I've got some slides here. Maybe repeat for some, just because we're starting a new round of this kind of research. So I don't have a lot of new stuff, but we'll go through and talk about this a bit. I always spend a little time right at the beginning talking about the parts of the planner, just so you know what I'm talking about. We're looking at a row unit here. I think that starts from the toolbar. We have our link arms going back that connect the row unit to the toolbar. Above, outside of the view of the picture, we have a seed hopper. We have an insecticide hopper at the back. Starting at the front, we're using row cleaners in a completely tilled situation in this picture, so that doesn't make a whole heck of a lot of sense, but there they are. So we have row cleaners, we have a no-till coulter up front. Behind that, double disc openers with a seed tube between them. That's where our seed comes down and gets dropped into the soil. Most of the older machines have a tube, and then some of the newer technology that I'll bring up is basically brushes that moves the seed from the hopper or the metering plate down to the soil. One of the cooler things about that, if you didn't know, is those brushes are paired with the speed of the tractor. So you generally have to have GPS or some other speed input into that tractor or into your planner system to be able to control those brushes. And what they do is they throw the seed backwards at the speed you are traveling. So essentially they're achieving a dead drop of the seed so it doesn't roll in the furrow. So really cool, interesting technology that we're implementing there. Gauge wheels behind the double disc opener, setting our depth. Those can be manually adjusted on most planners. Other planners have automatic adjustment on them as well. Usually there's a seed firmer of some sort behind that. Sometimes there's also fertilizer application system attached in this region as well, thinking 2x2 or in furrow. Sometimes that goes through the seed firmer. And then at the back, we have our closing wheels that close the furrow. So overall theme for today, when we're talking about planting, and that could be corn. I generally think of corn when I think of planting, but corn, soybeans, or alfalfa in the end of the, based on what we're talking about today. Plant at the right depth, cover the seed and close the furrow, and we want to achieve seed to soil contact, okay? So I'll talk about the planter I use in some of my research just a little bit. I won't spend too much time on this, but basically a 4-row Deere MaxEmerge 2 with vacuum row units. We use Ag Leader precision ag technology on the field computer for control, and we also use them for electric seed plate drive on the planter as well. And we have a generator that supplies the power to that, all sort of run by hydraulics off of the tractor. We're also using a Dawn equipment system to control our hydraulic downforce, our variable depth control on those gauge wheels, and then variable closing wheel depth and pressure. So there's a pneumatic system on this thing as well that makes sure that the gauge closing wheels aren't running too deep, throwing seed out of the furrow. And then we try to basically replicate what farmers are doing in the field. So I'm not running an Almaco type. It's not a plot planner, although we call it a plot planner, but I run it at field speeds as best I can. So 5 miles an hour with guidance in that system as well. Quick picture of the planter. This is a few years old. I need to, we'll probably update that this year. But we're looking at the 4 rows, had the big seed boxes on it at the time. I've since replaced that with the smaller ones because the large ones just aren't necessary in what I do. And you can see we're running a similar thing to what I had in the picture in this image. So we have row cleaners up front, a no-till coulter, and then all the way back through the double disc openers, gauge wheels, and closing wheels. So a couple of years ago, we spent a lot of time looking at these closing wheels, something I will bring up that we're sort of getting into in this year as well. Kind of a soft opening is kind of the way I'll say it. Is we have a bunch of these closing wheels sitting around. We also had a conversation with some of the closing wheels manufacturers, and they were willing to participate. So I'll give you the sort of the answer to this question before I present the research results. Is it closing wheels are sort of soil and condition dependent, and so for one to work better than another, it just depends on what soil you're in, where you are in the state, what soils you have, and how well they close the furrow. So what we decided to do, and I'm working with Sam Bibby and a few others on this, is we put together what we're calling the Wisconsin Closing Wheel Library. So basically, we're taking some of these closing wheels I've tested. They're sending us a few of their new offerings to put in that as well. We're taking one row of each of those and sharing it with our county educators, regional educators across the state. So if you're a farmer, crop consultant, et cetera, and want to try a bunch of them before making an investment, it is something we will be able to do. Get a hold of me or Sam or a few others. Let your regional educator know, and we'll be able to hopefully get you a set of closing wheels out and be able to use those during planting season for a couple of weeks to run them through the different soil types and see which one works best. So that's sort of the plan. We did this closing wheel research from 17 to 19 all over the state using the different types of closing wheels. I won't spend too much time there, but we will go into the 4 closing wheels. So we worked with the Sugar River Watershed Group in this instance, and they kind of defined what closing wheels they wanted to see, the ones they were interested. So we had a curve tine at the upper right, a paddle type at the lower right, a spike closing wheel at the lower left, and then your standard everyday rubber and plastic closing wheel was kind of our control setting for this study. Planted into everything from cover crops, corn stubble, every bit of it was no-till in this situation, and tried to see if we were able to change emergence based on the closing wheels we had installed. So long and the short of the results there, these are all open source, open access journal articles. So you're welcome to go take a look and read the minutia of how we did the work. But the answer in 2017, standing sort of by itself, was that we had aftermarket closing wheels did 2% better than the standard closing wheel. So no one closing wheel presented as the best closing wheel out of them all. Because we had quite a few different soil types and other things going on. There was a lot of variation in how that corn emerged. But we did see strong significance that when we lump all the aftermarkets compared to the standard, we got about 2% in 2017. What I'll say about 17 is that it was pretty much your standard good soil conditions for planting. So the moisture was good. Everything was sort of in a good condition when we were in the field that year. Moving on to 2018 and 19, we had a little bit different situation. So what I will tell you it was wet those years, and we sort of more or less mudded the corn into the ground is what I'll tell you. So we had a little oddball planting year, but everybody was dealing with that. So we moved on with the study. We also incorporated down pressure into this study. So basically we were looking at high and low down pressure, and I believe the high was 350 psi on our gauge wheel load, and the low was 150 psi. So we still had down pressure present. Didn't remove it or lift up on the row units, but we did place that down pressure at a high and a low setting. So in the wet planting season, what we wound up seeing is better emergence in the low down pressure situation. So 92.1 compared to 90.7. What we were actually doing in our interpretation where we were planting the seed too deeply with that high down pressure. So not only were we keeping the gauge wheels on the ground, but we were actually pushing the soil down and planting deeper. So when you look at the aftermarket versus standard closing wheel plot there on the left, we saw that low down pressure with just the standard closing wheel did the best out of the emergence at 92.5%. That's kind of a bad news for a researcher, but I also have a pretty decent story to tell because of it, because the situation we were in with the wet planting conditions, it just worked out well where that rubber closing wheel mashed that furrow back together. We got good seed and soil contact when we did that, and it gave us good emergence, and that was the situation we were in. But what you'll also notice is the high down pressure with that standard closing wheel was the worst at 89.5% emergence. 89.5% emergence isn't bad, but just not quite what we're looking for in this situation. So what we noticed there was we were planting a little deeper than what we should have been because of that high down pressure. In addition to that, mashing that furrow back together basically caused us to reduce our emergence. Seeds had trouble getting out. What I will say is the high and low down pressure on the aftermarket closing wheels, where we were doing that little bit of tillage above the seed, were obviously not statistically different and not different from the standard closing wheel in either situation. So the way I like to put it is these sort of aftermarket closing wheels in that wet situation alleviated some of our, for lack of a better word, sins for having too much down pressure on our row units, and allowed us to achieve that above 90% emergence in that situation. So just something to consider when you're looking at these closing wheels and thinking about maybe putting some on. They're not going to be a silver bullet. It's not something that, if you put on a set of closing wheels that does a little tillage, you're going to get great emergence. Well, there's a lot more to it than that. But what they can do is save you in a situation where you had your settings a little bit off while you were planting. So the other thing I'll spend, excuse me, a little time on is active downforce systems. So looking at the hydraulic or pneumatic downforce and being able to change the downforce on your row units across the field. A lot of reasons to potentially do that. When we have different soil types within the same field, some may do better with a lot of downforce and others do better with none, depending on the types of soil. I'm not a soil scientist, but I sort of have a few friends that are. So some of those conditions may change during the day while we're planting too, right? If the soil's drying out on the ridges and things like that, you may need a little more force to get that furrow open properly and plant the seed at the depth that we want to plant it, get it closed. So I think investing in active downforce systems is probably a good thing if that's the next sort of step in your precision ag journey, is the way we'll call it. They're nice to be able to adjust that downforce from the cab and make sure you're achieving the proper depth. I did pretty much cover all of this. We're kind of looking into the soil moistures, variation in moistures, types, etc., and making sure we're planting at the right depth with our active downforce system. So I won't spend a lot of time here. We have done some work. There's some publications out there that talk about soil electrical conductivity, which is kind of like water holding capacity, in a very, very rudimentary sense of the word. Might be a good way to create sort of a map if you wanted to vary the downforce across the field, but I don't have anything definitive to say that's the best way to do it. May put a slide in there different, but what we'll do is talk about this study from Alabama. And again, back in 2017, this is a little bit old data, but it is sort of an interesting thing where they did 3 planting depths in corn. So 1.7, 2.8, 3.7 inches, 3 downforces across all of those, and emergence was counted at 75 and 100 growing degree days. Couple of things to note here. There was a wet year and a dry year. So if you look at the depths in this situation, it's very similar to what we found in our closing wheel study, whereas as you increase the seeding depth or increase downforce, I think downforce is the next slide, you're starting to see a reduction in that wet year, which was 2014. In 2015, a reasonable year, a year where there is soil moisture, but not necessarily soaking wet, the seeding depth didn't quite bother it as much. Similar story here with the downforces as well, where we're looking at 14 versus 15 and not seeing, too much different across the deal. But as we increase our seeding depth and our downforce, we're starting to see reductions in emergence. So in summary on that study, weather was a driving factor. At normal temperatures, normal soil conditions, the down pressure and depth didn't have an effect. With cooler temperatures and shallow receding depth, achieves higher emergence when the soil is wet. So just similar thing to what we saw in our closing wheel study, where make sure that your planting depth is what you need it to be. And in some way, I'm looking at it here. If it's a little bit wet, you might consider planting on the more shallow side in order to get that plant out of the ground more quickly and get it growing and using that available water. So some setup considerations to touch on here quickly. I will tell a quick story just to make sure everybody's aware, but the vast majority of planters have left-handed threads. So I've told this story before. I don't know if I've done it on Badger Crop Connect, but basically we were trying to replace the bearings on one of the left-hand side of the planter and taking the double disc opener off. So the right-hand side, looking at the back of the planter is what I'm saying. The right-hand side came off just fine. I handed the student a impact gun, air impact wrench, and he basically said, I just can't get it to loosen up. I'm guilty as well. I got down there and righty tighty, lefty loosey, made sure everything was right, and it just wouldn't loosen up. Turns out when you use a big enough impact gun, anything will loosen up, and we wound up stripping the thread straight off of that thing. So we had to do a little emergency surgery on the planter to make the stud back to a normal situation, and realized, oh, that was left-handed threads, and that's why it wasn't moving. So just bears mentioning that if you're working on your planter, anything on the left-hand side when you're standing at the back will generally have left-handed threads, so it doesn't loosen as it's running through the field. And pay attention to that. Otherwise, you might have a little bit of a costly repair to take care of. So I can't talk about setup and machinery maintenance and everything else without touching on safety a little bit. So we'll spend a little time here making sure that if you are crawling up under one of these machines to do anything, even if it's one of those situations where I won't be under there but just a minute, I would highly recommend blocking up the planter, locking out hydraulic cylinders if possible, and making sure that nothing's going to fall. It only takes a second for a hydraulic line to burst. And even if it doesn't have pressure, it could still be holding weight that's causing it to have pressure, and you just need to be extra careful in that situation. Don't trust hydraulics is what I'm trying to tell everybody. So just make sure we're safe. Blocks, anything under something solid that'll hold it up high enough that you can get out from under it if something does go. Planter components are sharp by nature, so we're obviously cutting through the soil, cutting through plant material, cutting through whatever. So they're generally sharp and sharpen themselves as they go through the soil throughout the year. So gloves, safety glasses, etc., are always a great idea to keep yourself from getting cut. And like I said, accidents happen when you least expect them. So I just make sure that everybody hears me say it, that, don't crawl up under a piece of machinery being held up by hydraulics, and, that I'll just be there a second. That's when things happen and we don't want them to. So now that I've said that, let's spend a little time. I will say that every planter is different. So checking those owner's manuals for specific tolerances and adjustments on your specific machine is the way to go. But making sure that, in general, wear on components is a big influence here. So we want to make sure we're doing stuff to make sure that the planter is operating properly and able to put that seed where we want it to. Little story I'll tell too, when I got my planter, it had been used as a replant machine somewhere in Indiana. And I don't know how many acres that planter had been over, but it obviously was quite a few and probably did a lot of turning at the same time, because when our link arms mount to the toolbar and back to the row unit, there's a couple little bushings and things in there. And I actually saved them. I didn't bring them up from the lab this morning, but they were solid steel bushing, very, very round when they were originally manufactured. And when I got them off of this planter, they had a link arm size groove cut in them, where this planter had been, up and down and left and right and doing all the things that planters do. So when you grab the row unit, I can move it an inch or two either direction, left to right. And really what it should be is straight behind the planter and not moving. Those bushings were just plain old worn out. So pay attention to a lot of that stuff. And as you see things wearing, it's cheaper now to replace something while it's still working than it fails and something breaks, and then you have to replace more than just a small bushing because it fell off or whatever, going 5 to 7 miles an hour down the field. So looking at the parallel link arms, what I was just talking about, bolts are tight, torque to spec, bushings are in good condition, side to side movement shouldn't be excessive. You should be able to move it a little bit, obviously, but not a lot. And we want to make sure the arms aren't bent or binding as the row unit travels up and down. So that is the sort of the suspension for the row unit as we go over things like we don't have any of these in Wisconsin, but rocks or other things in our field. We want to make sure that row unit can move up and over those things without damaging too much, get back to doing its job when it comes back on the ground. Seed tubes, you want to make sure they're installed properly, not cracked or broken. Also taking a look at that seed sensor, making sure it's relatively clean on your planters. If you have that little, interrupted image seed sensor, that provides you good information about whether a row unit's planting or not and the population you're planting at, et cetera. So we want to make sure that they're functioning and doing what they're supposed to. So if we do get a stopped up seed tube or something happens out there, we get alerted pretty quickly and don't have 10 to 12 passes with one row not planting, because everybody at the coffee shop down at the next town over will be talking about you. Don't forget. Looking at the double disc openers, we should have 2 inches of contact at the soil engagement location, which is basically 45 degrees towards the front of the planter, off of level from the center of the spindle they run on. So the way we generally check this, or the way I've seen it checked, it's kind of hard to slap a tape measure there and make sure that you have 2 inches of both of those wheels contacting each other. But if you have a business card or even just a sheet of paper and put one on the top, one on the bottom, and then you can measure between the paper and see how far they're contacting. You don't want them contacting too much because you'll have a little excessive wear there. You'll be wearing them out quicker than you intended to. And if there's a gap, you're obviously not creating a nice solid V for that seed to fall into. Shims are installed and can be adjusted. Again, that left-handed thread thing, I'll bring it back up. You have to take those off to put the shims in to make sure, or take shims out to make sure you have at least 2 inches of contact. Worn or cracked blades are bad deals on planters. If you have a crack running through one of those, the next rock you hit, you may have not a disc, but a double shard opener. So be extra careful, double check them for cracks or overly worn. Lubricate the bearings if you can, may even require hand packing. And I brought up the left-handed thread, so I won't belabor that anymore. Gauge wheels can be worn too far and cannot be set properly. So they should be, and generally they should be touching the double disc opener, but not touching so much that they're hard to move. So you want them to be rubbing, but not quite bound up on that double disc opener. You want to check the bearings to make sure no wobble is present, and make sure they're running true alongside the double disc opener, and free to move and interact with the depth stop. So that's one of the more important things on the planter, in my opinion, is when you set that depth stop, those gauge wheels should be able to rise up and bump that, and that correlate directly to whatever setting we're putting it at. So basically, if we wanted to plant at 3 inches, I want it planted at 3 inches, and that's something we can check in the field or in the shop when we're doing. Seed boxes are another thing, and when I say seed boxes, I mean metering units as well. Looking into those, but in this case, cleanliness is the best thing ever. You want it wouldn't hurt to vacuum those out. Make sure not too much excessive graphite or talc or whatever you're using for a seed lubricant is in there. We don't want clumping seed lubricants and causing problems throughout the planting season. So I usually give mine a shot of air or vacuuming or whatever before I even leave the shop. Foreign material obviously can clog the holes in your seed plate, etc. Cracks or broken parts make the thing work like make it work like it's not supposed to, I guess is the way I should say that. So we want to make sure all the parts are in good shape and the brushes are good when knocking the seed off, whatever seed removal or planting system that you have. The other thing I'll tell you too is those seed boxes, the lids look like they're on there pretty good, but going 70 miles an hour down the road, Student and I learned pretty quickly that we had to double back and pick up a bunch of lids. So I would take them off if you're going any faster than tractor road speeds, just so you're able to keep up with them. Closing wheels, real quick, they have bearings, so being able to pay attention to those, make sure they're not crunchy and running goofy. They do have left-handed threads. And then the pivot bushings should be checked too for wear if they're replaced. So that's the arm that the closing wheel is attached to. There's two bushings toward the front of the planter up there where that is allowed to rotate and pivot and let the closing wheels bounce over things. Finger meters are another thing to talk about if we're still running those, which they're not a bad thing. It's just not everybody's using them anymore, but they have springs and moving parts and probably ought to be checked, cleaned, and at least lubricated with a dry lube of some sort to be able to work properly. Vacuum meters is the same. And then we might want to make sure that that vacuum system doesn't have, heaven forbid, a rat's nest or anything in it to where we're moving a lot of debris through that system, because the fan doesn't take impact very well. As far as the transmissions go, like I said, on my planter, I have an electric drive, so making sure the wires are good, mice didn't chew, etc. Look, if we have chain shafts and transmission, just make sure everything's tight and in proper adjustment. Worn chains, stretched chains may need to be replaced, lubrication. Make sure all the cogs and sprockets all have all their teeth, so we don't have an instance where we could jump a tooth and the whole thing stop planting and we don't know it until 20 passes later. And then road cleaners and front coulters, just check for wear and bearings, make sure the settings are correct when you get to the field. I will spend a little time on road cleaners just briefly. Excuse me. We don't really want to dig a hole with our road cleaners. So when you're setting those up in the field, you want to make sure that you're not doing tillage with them. They should be brushing the ground. They may move a little bit of soil depending on the unevenness of what you're planting into, especially in a no-till situation. But we're not doing tillage. So you just want to move in the residue out of the way, kicking a few clods here and there, but nothing more than that. Depending on your system, some people have adjustable row cleaners from the cab, either on pneumatic or hydraulic system. Others, like mine, are fixed position. So if I vary my down pressure on my gauge wheels,
Just
the depth
waiting
of my
for
row
folks.
cleaners are set to the gauge
You
wheels
just
as
have
well.
to, you just have to take a picture or something.
Oh, that's somebody else. I figured Liz will handle muting that. But long story short, basically, if I put too much down pressure, I'm pushing my row cleaners down into the ground as well. So I need to make sure I make that adjustment as I do it. Front coulters, again, they should be 1 inch shallower than the planting depth. So you want that front coulter to run about 1 inch shallower than your double disc openers. So the double disc openers make the last cut where the seed falls in. They do cause additional draft force, but they do cut residue as well. So we found on a couple of studies they're pretty good in getting the seed in the ground, helping get the furrow closed as well. So last thing is technology. Anything you have, field computers, guidance, etc., on your machines, you always update everything at least annually. Turn it on, update it at home, not in the field. Just in case something doesn't work, you've got a little time and a little effort and somewhere that a service tech can come if you need them. Always check the wires and the wire connections. A chewed wire can be hard to track down. Again, ask me how I know. And then most monitors have calibration mode to spin the seed plate. So every year I do this as well. I trick my planter into thinking that it's in the down position and tell it I'm going X miles an hour, and it starts planting seed, and we catch all that and count them to make sure my seed plate number in the computer's right, and I'm planting at the number of seeds per acre that I want to. So just an easy way to check, and you can do it on a few rows. And obviously you can do it on manual systems as well. It doesn't have to have the technology there. Just a quick thing about planting in no-till. Corn stubble's one thing, 3 inches of rye is another. We've been doing this for a couple of years, and I think we're going to get started doing a little bit more with this soon, or at least I hope we are. Roll crimping, we have some vetch here and everything else. So being able to plan into that is kind of an oddball situation, but I do have a toolbar full of steel on my planter to generate enough downforce to cut through all that and able to achieve almost the right seating depth in corn. I think the planter design needs to be a little different to where I can get an extra half inch out of it. I aim for 3 inches and I wind up at 2.5 basically every time because of that extra, inch and a half or so of residue. So basically we are able to get a planter to achieve a proper seating depth or mostly a proper seating depth in these serious high residue no-till systems. Got a little video here. I'll see if it'll play, but just to give you an idea what it looks like. The only thing that makes me nervous when we go out here and do it is I'm from Kentucky and we had some karst topography down there where I'm from. So that meant tile holes, sinkholes, etc. If I've got a field rye looking like this, I don't have much time to see that hole coming at me. So hopefully we don't fall off into them. Not too much to worry about here around in Wisconsin, as much at least in the southern part. So last thing I'll talk about quickly is when you get to the field, check again. It was my job as a kid. We'd plant the first 100 feet, and I had my little motorbike and a pocket knife. I was so excited to have that, and I would go out there and dig, seed and measure how deep it was, and so just making sure that the gauge wheel setting, row unit downforce, everything is working like it's supposed to. You're planting at the depth, and you're getting that furrow closed. I would say test passes should be with the planter in the ground, obviously, but actually up to speed as well. So just going real slow and dragging that planter versus going 5 miles an hour looks very different to the forces that the gauge wheels and everything's seeing. So I would go a little further, make sure you're at depth. Heavier soils require more pressure. And one other thing to say is planters without central fill. If we're running with seed boxes on the row unit, they actually lose weight over time when we put that seed in the ground and reduce the weight in them. So just something to think about there is your down pressure may need to change if you're doing it that way. With that, I think I've basically hit my time. A few minutes here, there, everywhere, but I will stop there for questions if anybody has them.